it's important before we talk about what is STEM to talk about the need for STEM, because there's a lot of interesting statistics coming out about the quality of science, especially education, but also engineering, technology, and math. So here are just a few neat facts about STEM education. First of all, it's not just a lack of a proficiency in the subject, it's also a lack of interest in the subject, and that's a major problem. And that's why our curriculum will focus so much on careers, to get kids interested in STEM fields. And this is a really hard to see but interesting visual, is that first big ball, that represents almost 50% of 12th graders are both low interest and low proficiency. So even if they had the desire, they don't have the skills, and if they have the skills, they don't have the desire, so they have neither. 25% have low interest, but they're actually very proficient. So they might have really strong math skills, but they're not interested in a STEM career. 17% are the high interest and high proficiency. So those are the ones that we really want going into the STEM fields. And then another 15% have the high interest, but they don't have the skills that they need to do it. So out of all the 12th graders, only 17% of them actually are ready and willing to take on a STEM career. So there's a major problem there. Secondly, when we compare American students to the rest of the world, our skill level in those subjects are really low. And this graph is really hard to read, but I'll show you where the U.S. is. We're right here, and this is in reading. So in all of the economic, if you look at that, these are all very high economic countries. We rank okay in reading, but if you follow this all the way down to math, we're almost towards the bottom, and then we're just a little bit better in science. And so for the quality of education that we have here in the U.S., we actually have very low proficiency in some of these skills. And then this is another really interesting, that our current generation of adults aren't really that much better. They've done a lot of different surveys, but the percent of U.S. adults that are rated scientifically literate is under 30% of adults. So you might ask them a question like, those questions at the top are science facts that adults got wrong in a survey. And the sixth one is they think ordinary tomatoes don't actually have any genes that genetically modified tomatoes do. So if they were to ask an adult that question, 50% don't think that tomatoes have any genes in them. So obviously that affects us, because people vote on things related to genetically modified foods and have opinions, but they don't really even know, that genes are good and naturally occurring. And then it also shows those U.S. performance on science tests is also very low proficient, and the other percent below basic is actually really high. So we're not doing too well. So I think that video emphasizes the point that there's careers out there, and we want kids to be prepared to take on those careers and not have their chipmunk be the number one thing that comes up in a job interview. So hopefully they would have the skills ready to take on those jobs. So what does it mean to be prepared for these jobs? We know that they're out there, so how can we prepare kids? There's been a lot of recent research about characteristics of a STEM student and a STEM classroom. So when you look at a STEM student, you really want students that have that technological literacy. They can think and solve problems, and they can even solve problems that relate to the culture. So, for example, we were talking about in our group that might be regional. So, for example, if they have a problem regionally, they have the skills and they have that awareness that they need to know what's important in their own community and be able to solve those problems. And then a STEM classroom is very active and creative. There's a culture of questioning. A lot of times you hear teachers, they think that questioning is not good, or that it's kind of the students being cheeky. Well, it's really good to ask questions, and they want them to inquire and want to know why that works and how it works, and it should have a culture where that's okay. It's really student-centered. And then finally, that last part, formative and performance-based assessments. That basically means instead of taking a test, which is typically performance, there's also things like giving a presentation where their class rates them. It's much more flexible. Or the teacher asks them to create something, but it's not graded. It's just so the teacher knows if they're doing it right. So it's different ways of assessing other than a test, although those are there too. There's that performance part, but most of it's not necessarily testable. And then finally, the idea of integrative STEM education, and that's what that means is any more than 2 STEM disciplines being taught together. So STEM actually doesn't have to always be in the middle there. It doesn't have to be this spot right here. It can actually be over here where it's just math and technology. It could be up here where it's science and technology. It could be in any of these spaces, and it's still considered STEM. So it's really any 2 that are being taught together and using both of those skills, which I think is a big misconception. And then finally, do we integrate STEM and how do we do it? And first of all, how do you do it? Or what's a good way to do it? Is it by providing students the opportunity to construct new knowledge by designing artifacts? So you'll see in a lot of effective STEM integration is the kids will actually create something. So for example, in one of our lessons on food packaging, they don't just talk about it and draw it, they actually create the package of the food and they test it. If they're designing a way to transport livestock, they'll actually create a model of that. And so typically there's something that's created and something hands-on that they can do. The activities are very open-ended. There's not one right answer. It's really important. It relates to a theme. That's the most effective way to do it. So instead of a bunch of unjoined things, we're hoping the theme's agriculture, and so the theme's really important. And then it involves students in solving authentic problems. So instead of just doing it for doing it, the students actually feel like they're part of solving a very realistic problem. One of the problems that we were working with the past few days is putting a kid in a situation where maybe the animal's not eating well or the animal doesn't have the qualities that it needs. Well, what would you do as an animal nutritionist to help that animal? So it's putting them in really authentic problems. And that's just a cute picture of some kids doing science. And then some of the benefits that they've been able to see from STEM integration is that the kids can take knowledge and actually apply it, which is very important for job preparedness. They're much more motivated to learn and engaged in learning. And then even with all that, they actually do still see those math and science test scores go up. So it's not just remembering the facts, but it's being able to apply it in real-world situations. And then finally, at the Superintendent of Public Instruction STEM Task Force meeting, they asked a wide range of science and STEM people, what is STEM education? And this is what they saw, or this is what they created. They took all of you'll notice it's weighted, so the most popular answers are the largest ones, and then there's some small ones that are kind of unique. There's one that was really funny, I don't remember, synergistic. So this, you can kind of see a theme there, some of the things that they thought were the most important. But obviously not everybody had the same answer. There's a lot of different answers when you talk about STEM education.